19 years in June. I'm going to talk about a number of different things today. And I appreciate the opportunity to be here, Dean, Lauren, and the crew. Primarily the four different areas that they asked me to discuss a little bit with you. And principal among those are going to be some soil health testing using the Haney extraction, the Salvita methods, how we present the data to you, what we've learned with soil health testing in the last 3 to 4 years, and still are learning about it as we go forward. A little bit on micronutrients, what kind of the trends we're seeing with micronutrient usage, micronutrient levels as we're determining them in the lab, and a little bit on calcium fertility as we get into looking at some of these different tests that we're using with the soil health measurements, how they are showing some numbers that are different than our normal extractions that we're using in the laboratory. So from the standpoint of trends, and what we're going to look at is some data from the International Plant Nutrition Institute. IPNI is what will be referred to in the following slides. We're looking at the medium values. I just threw that up there with a definition from Webster. And all that means is the value that shows up on the maps that you're going to see are something that's right in the middle in what we determine or is determined by land-grant universities in the various states as to what a critical level is. This is where you should be or need to be for optimum production on any crop. So we look at my coffee cup. We look at grade values, and what the international, what IPNI does is take, no matter what the extraction method is, from any of the labs they're using, and there are, I think, 75 or 80 labs that contribute to the data, including the private labs and the land-grant universities. There are over 3 million soil tests that are represented in this data. When we look at Minnesota, what we consider a critical level is 20 parts per million. Our neighbors to the east look at 25 parts per million on a bray extraction. Personally, I agree more with our neighbors to the east than I do with some of the other universities in the Midwest as to what we should be at. 25 to 30 parts per million on a bray level for phosphorus I'm pretty comfortable with. And this goes back to the days when I was in the consulting business, and those were the numbers I was hoping to achieve as well. So what percent of all those samples are testing below that 20 parts per million in any given state? Again, looking at Minnesota, we're at 47, almost 50%. So that means we're below 20. We're somewhere, and I guess the lowest I may have seen with a bray extraction might be 7, 8, or 9, which is a very low number. Wisconsin at 48%, Iowa at 40%, South Dakota, North Dakota is even at a lower level than we are. And only the states that have at least 2,000 samples represented are shown on the map. We also look at ammonium acetate extraction. This is the method that we use in the laboratory to determine potassium levels. And again, we're looking at by state what the critical level is in each state as determined by the various land-grant universities. In Minnesota, our neighbors to the west, 160. And then Wisconsin, as we move to the east, is a little bit higher at 170 parts per million on a soil test level. Again, in conversations that, when Dean shows the data from the harvest, or from the combine, as the guys rolling through the field, and we're seeing 200, 300 bushel corn yields, we're not generally getting that with 160 parts per million. Most of the dealers, consultants that I've had conversations with as we got through harvest are keeping their parts per million on potassium up closer to 200 on our soils in this part of the state, the country. And that's a pretty good level to be at, although I don't know if that is still the optimal level. In any discussion we have year by year with dealers in any states, we're looking at potassium as a critical major element that we might be ignoring a little bit. As a matter of fact, last year in Wisconsin, and they had a great growing season this year, but last year in the university research plots, they found more of a yield advantage to apply additional potassium than they did to apply additional nitrogen. And that may be why they're raising their level up a little bit higher on these reports. With that being said, we've actually gained ground. Now, what IPNI has been doing since the year 2001 is taking these averages, gathering this data about every 5 years. 2001, 5, 10, and then 15 is the last season, or last year was the last season. We've actually picked up a little bit in potassium in Minnesota. Wisconsin has gained some ground. Iowa's gained some ground. But still, when you look at the percentage of samples that are below that critical level, we're still at 47% or close to 50% of the samples analyzed by all of the laboratories contributing to this data set being below that 160 parts per million. So the message really is, where are you at? Are you at a critical level as you review your soil test reports with Dean and Lauren and the guys at the office? Where are you at? Are you at a level that you need to be at to optimize your yield year in and year out? If there are any questions as I'm going through this, feel free to just stop and holler, raise your hand, yell, holler.
Question there. There's big differences from state to state and the change over the last 5 years. What do you contribute that to, Jim? Is that part of the livestock intensity that's have a big influence?
You mean this map right here?
Yeah.
No, I don't know that livestock intensity would be it. If you look at, as we see when our samples roll through, there's a relatively decent level of potassium in livestock manure, but it's not generally, when you're restricted by a nutrient management plan to a nitrogen or phosphorus application rate on manure, you generally aren't getting enough potassium to maintain a soil test level. So unless they're adding some K in those systems, I don't know what's attributed to that. Other than I know that in Iowa, and they showed the 160 part per million as a critical level. Antonio Malorino down there is in his thought process, has raised that to 200 up to 210 as the critical soil test level that he would like to see. So they may be jumping on the bandwagon in Iowa and bumping up their potassium fertility recommendations and applications. Wisconsin is getting there. They're moving in that direction as well. And we probably will get there here in Minnesota someday too. Anybody else? Looking at pH sample distribution, and this is a comparison between 2010 and 2015. And you can see we doubled and then some the number of samples we're looking at. But really what's been pretty consistent is that these bar graphs haven't changed a whole lot. So we've kind of maintained the same number of samples in a given range. Maybe we're up a little bit over here on this side, the 6.1 to 6.5 range, the 6.6 to 7 range. And ideally, if we're looking at crop production and almost anything, this is kind of the range we want to be in on our soil test levels. So at a frequency, we're at roughly 20%, where we're at an almost optimum soil test pH level. We're also going to be seeing some of the soils in those areas that have naturally high pHs like we get into in western Minnesota. And you don't see too many that are over 8.5, and it's just a soil test at a high pH level like that is just a really difficult one to manage. You should almost be trying to ban your fertilizers when you get over 8.5. The only micronutrient that IP and I looked at was zinc. And again, their sample distribution. We've increased by almost fourfold the number of samples that had zinc run through the laboratory to analyze for the critical part per million. is 1, as determined by most land-granted state universities. So we're doing a little better. Back in 2010, we were significantly higher at those that were below 1. We gained ground, we're between 1 and 1.5, and then over 1.5 has gone up as well. In our determination in how we would make a zinc recommendation, the amount of phosphorus in the soil sample comes into play a little bit, and the CEC and the calcium, magnesium levels in the soil profile can affect zinc uptake too. So we would look at a critical level on our, where we would make a recommendation might be at 1.5 to 2. If it's below that, you may see a zinc recommendation. And to be totally honest with you, if you're planting corn, you should be putting zinc in with your starter anyway, at some level. And if you want to build your soil test level, and we do have some dealers and consultants that are recommending that in different parts of the state of Minnesota, they're starting to broadcast some zinc sulfate at an equivalent level of maybe 5 to 10 pounds in a fall broadcast or a spring broadcast. And that builds your soil test level enough. We're talking in micro, we don't need a lot, but it builds it enough that it kind of maintains for about 4 or 5 years. With that being said, they're still putting zinc in their starter at a lower level, so we have that early season availability. Any questions on any of that? You can go to that website, IPNI, and look at all these maps. There's, if you want to open an account, you can do that too, but it's all on that website. You can just scroll through some of the different sets of data.
How much sulfur are you supposed to put on a year or what?
Sulfur, you know, they did have a chart on sulfur, but they're not using the extraction we use, and I didn't know how to convert it, and my lab agronomist said he doesn't. The reason we changed to an ammonium acetate extraction is we thought it was a cleaner extraction and more accurate. So I didn't show that one, but as to how much sulfur should you be putting on in any given year, on virtually almost every soil test that I see, and I don't see all of them that come through from the state of Minnesota, we see parts per million at 10, 11. If you're growing corn, I would be somewhere between 20 and 25. And I know that's going to be higher than the university. Part of the issue I think we're seeing is if we don't stay up at a high enough level, we're getting to the back end of the growing season where we need sulfur, that nitrogen-sulfur complex to create proteins in our grains, we're running out of it. So if you want to take part of that 20 to 25 pounds of sulfur, and apply it as an elemental in the fall of the year so that it does become available later on in the growing season, that's what some folks are looking at doing. But it'd still be within that range. To be honest with you, I'd split it up. If you're doing any kind of side dressing of nitrogen, I would make sure I add some sulfur into that. So it'd be 28% biosulfate, surface broadcasting urea, maybe a little bit of AMS with that. And that helps get you to that back end sulfur level. Anybody else?
Can you go, we have a question quite often, how many phosphorus, sulfur, elemental sulfur, how many parts per million, how many units of sulfur to raise up a plant or
Well, it depends a little bit on the soil type, but if you want to raise, in your soils around here, if you want to raise your potassium level 1 part per million, you probably need to put on an additional, over and above what it is now, taking into account crop removal, about 5 additional pounds of potassium to increase it 1 part per million in the soil test. Phosphorus, the range is anywhere from 10 to 35, depending on your soil types in the CECs. Up in the Red River Valley area, it probably takes 30 pounds of additional phosphorus. Applied phosphorus as a fertilizer to raise it 1 part. Here would be about 15 of product. Or used per, yes, sir.
Is it critical to put X amount of product on. I know we talked about getting our P levels in a manageable, so that they're not necessarily equal, but they fall within a range. Is that a bigger issue than actually putting on X amount of pounds or whatever is sufficient to keep the balance there?
Yeah, the word you used in that question was range. And if you didn't hear the question in the back, is it more important to look at a specific number or be within a range on a specific number? And I've always been, and we'll see data a little bit later on that shows you that number from the soil test you might have taken a month ago could be completely different if you were managing to go out there and punch a hole in the ground today, just because things have changed in that system. We look at it as we're doing a chemical. We'll talk about that more as we get into this. But there's also biology down there that's changing that thing constantly. Bringing nutrients into play, or in some cases maybe locking nutrients in. So yes, it's more important to be in the range. So if the goal is 20 parts per million or 25 parts per million, if you're somewhere between, say, since 25, since that's my favorite, if you're somewhere between 22 and 28 on a set of soil tests over a period of time, you're in the range that you should be in. There's a role that all nutrients play in supporting microbial life. Sulfur is part of the organic matter complex. There's a fair amount of sulfur. I don't have those numbers up here. But anytime you are showing a lack of sulfur, you're not able, whether you're a microbial, microbes in the soil profile, bacteria, mycorrhizal, or even within the plant, you can't form complete proteins. And the proteins are part of the structure. All living structures that you and I, plants, microbial populations. So, what is an adequate level of sulfur? We used to get it kind of came free from the atmosphere before we cleaned that up. Where we see optimization across a return from a yield or an application of sulfur on a soil test level is somewhere between 15 and 20 parts per million on a soil test level. You should have an adequate supply of sulfur for just about virtually every crop we're going to grow up here. Okay? Kind of? Yes?
How about copper or boron in this area?
Boron is an anion in the soil, so we're measuring it, but it's one of those fleeting things that you saw 40 inches of rainfall on that graph that Dean showed. That's going to move boron through that. It's an anion, so it's a negative charge. What holds nutrients in the soil profile are clay structures that have a negative charge. That holds your positively charged elements. Most of your micronutrients are, whether it be zinc, copper, manganese, and iron, are plus charges. So they attach to those exchange sites. Boron does not do that. We take a soil test usually, and I would guess probably 90% of the soil tests we see in the lab are taken at 0 to 6 inches. If that much rainfall, if there was boron in the profile, it's probably below that. And to some degree, I think we see that with manganese, as that is the more mobile of the cation micronutrients in situations where you have a lot of excess rainfall. That might be moving down. So what am I saying? Well, let's double the amount of soils that you guys send into the lab, and then 0 to 6 and 6 to 12. And then I'm also sure whether that's what's happening. I might play around with that myself next year. We're supposed to have a project every year. Some years we have, some years we don't. But I'm kind of curious to see if we're not measuring those micronutrients as should be at 1 part per million as a critical level, or really very close to that, but we don't hardly ever see that on the soil test when we are analyzing.
Are we putting on copper?
They use copper a lot in the highly organic soils. You get up into Big Lake in those areas that grow a lot of potatoes on those, either on some light sandy soils or what I would call peat or muck type soils where they're easy to harvest. We do see a deficiency, deficiency of copper in those soils sometimes. So we'll put copper on. If you're a dairy guy, you're getting all the copper you need if you've got a copper sulfate foot bath. I don't have that slide here, but I can show you one from Scott's. You've got plenty of copper. And that should also, again, be at that 1 part per million copper. So we don't need to have a lot of this. Are we getting enough? Tissue tests say yes, but we are looking at comparisons of some of these high yields. If we took a grain sample from that 300 bushel yield that Dean was showing on that video, what would be missing? I guess those, we're starting to do a little bit of that kind of work to see if we need to adopt or change some of our fertility practices to meet these requirements. I don't know the answer. At least on a tissue test at DT, it says good. You're fine.
But something we're not up for, so,
Sulfur, yes. Boron, I haven't seen anything. If you have an adequate supply of sulfur and nitrogen in your plant, and they start forming those complete proteins, then you've almost increased a native plant resistance to insects to a certain degree. Whereas they may be present, but they may not either like what they're chewing on and move on, or they have no effect on it. So sulfur maybe yes, more so than boron. Soil health testing, I'm going to go through some of these a little bit fast. Stop me if there's anything that pops up. 3 different categories that we measure on our report are the chemical, the nutrient levels that we measure in the lab, the physical. Looking at some of the water soluble differences between the different methods, analytical procedures we're using. The physical structure has large amounts of various sizes of pore space. We have large aggregate particles. Pore space for water, air, and oxygen in the soil system. You increase your organic matter by 1%, you can increase the water holding capacity by about 5,000 gallons per acre. Lack of compaction in soil texture. Higher and better organic matters, less of an issue with compaction. Some of that plays into calcium and magnesium levels in the soil profile. Then biological activity, earthworms, microbial respiration, and diversity in microbial species. That's what's all taken into account when we look at land management, your fixed soil types and characteristics, all contribute to the soil health and function. Organic matter, holding capacity, microbial activity, structural density, investment disease resistance. A lot of things, cover crops, or the addition of materials that generate or improve biological activity. And there are a lot of those out there that are actually doing pretty well. We offer 2 different types of soil health tests, a basic and a complete. The only difference is the complete test has all the micronutrients, soluble salts reading on it, which, again, with 40 inches of rainfall, soluble salts aren't going to be an issue in southeastern Minnesota because they move through the profile pretty quickly. So it's just the difference between whether you want the micronutrients or not. Okay, you can't really see this as well as I had hoped. But there are 8 different holes in there. And this is just a project I did at the end of the growing season for a soil health test. Taking core samples with 2 different probes very close together. And the reason I did it, because I had a call from a crop consultant out in South Dakota that said it's NRCS. Was telling the producers out there that you can use WD-40 on your probe when you take a soil health test. Well, when it's as wet as it can get sometimes in the fall, your regular soil probe doesn't go. You can't stick it in the ground without it getting all covered up. University of Wyoming and the University of South Dakota State University. Done the research work. WD-40 doesn't change the numbers. I had nothing else to do on those few days, so it was exciting. Of those 8 cores that you saw there, 4 are with WD-40 core. These are the results as they look in our laboratory. So if you look at the effects, side-by-side cores, with and without WD-40, this one has it. This one has it, this one doesn't, this one doesn't, this one does, this one does. Numbers stay pretty consistent across here. This is how we report all the biological materials, or biological measurements in the laboratory. Some of the other labs, almost every lab is doing something for the soil health testing. This is the way they report that data. This is the way we report it.
Can you go back to that last slide there?
Yep.
Those 8 samples were taken right in that picture?
No. That was one sample. That happens to be that group of samples right there. And that's my garden, so I know those numbers have been pretty consistent over the last few years. And I can't tell you why I have 17 parts of potatoes in that garden. Other than I keep digging up pottery shards every spring when I plant the garden. So there might be something down underneath. But no, those groups of samples were 4 with WD-44 without in 2 different sites in a small area to get the 8 cores I needed.
Do you treat a soil health test any different as far as do you dry it, or is it taken at a certain time of the year? Or?
Yeah, we're following Rick Haney's guidelines. The Haney test is part of it. We'll get into that a little bit. We dry it and grind it just like a regular soil sample because that's the procedure he developed. You don't change, which happens to fit in with what most labs were doing, and that may be why he said that. But he wants a soil health test 0 to 6 inches deep, and dry it and grind it the way a lab does. The salpida test is a log, that's taking that grinding ground sample and re-wetting it, putting it under about 115 degree temperature for 24 hours to measure the respiration of the biological material. So it's really not handled any different than any other soil sample that comes into the lab, other than we need a little boric bag to make sure we have enough to run all the procedure. So this is the how we present the soil health complete. Now this is just the chemical part of it that we would do in the laboratory on any soil test. So as you see, in most garden samples look this way. Underneath all 6 of those samples on the previous slide. That single digit N. So we know that, and we see that on our conventional test all the time. Manganese is 1 micronutrient that we're using. A little ground on it, we're not sure. Copper. I don't put any copper in my garden unless there's, you ask about copper. I always have that level of copper on my soil. Still one type soil, what is a little bit different, we'll see on maybe the next slide is at an optimum level here. But when we record it using Haney's extraction, we little more when they plant roots. Acidic releases should bring back into the plant. Or when they plant seeds, as the root exudates, start leaving the root system. Soluble nitrogen nutrients. My calcium level in my low garden is what it should be. So, there are a bunch of gypsum clouds. As we report the soil health side of it, we'll go into a little more detail on all these. We'll give you explanations over here as to what's happening, and this is all, here's the link to Rick Haney's PowerPoint presentation of my why and how